Hello physics friends, Mr. Collier here. Today I want to show you some examples of friction problems when forces are applied at angles or even when the object itself is on an incline. To approach these problems, we're going to have to split some vectors into their components. And the one thing that I want to point out is that we're always going to start with a free body diagram. So you'll see we'll draw a picture of every single one of these. So say a dad wants to move their 35-kilogram child across the snow while the child sits on a 3-kilogram sled. How does the normal force change if the dad pulls a rope upward at 35 degrees versus if they push downward? So there's always going to be a gravitational force pulling down on the sled, and there's always going to be a normal force pushing up. But now we have an applied force that is at an angle. This applied force is going to do a couple things. One, it's going to create some component in the x direction and some component in the y direction. And what that's going to do is it's going to mean that there's an applied force in the x direction and a frictional force in the x direction. But it's also that y component is going to increase or decrease the normal force. So let's take a look at that. When you're pulling up, the y component of the applied force is working against gravity. So you need to subtract them to get the normal force. What that means is that when you pull upward on an object, you're actually creating a smaller normal force and creating less friction. We'll actually work through some sample problems with actual numbers for this. And the opposite is true if you push down on an object. So if instead you apply a force at a downward angle, now the y component is in the same direction as gravity. And so they are working together to create a larger normal force. And so you'll have more friction. All right, so let's look at another sample problem where we actually do some calculations. Say you want to move a sofa from one side of the room to another, and you're pushing on it at a downward angle. What coefficient of friction is there if you have to apply 125 newtons to move it at a constant velocity? This is something that shows up in a lot of problems that really means a lot, but is only a couple words. If it's moving at a constant velocity, that means there's no acceleration. So that means that all the forces in the x and y axis are balanced. And that's actually a lot of useful information. So let's take a look at the picture. Here's my sofa. I've got an applied force at an angle. I've got a normal force. I've got a gravitational force. This applied force creates friction, but also that applied force has a component that's in the x direction. And it has a component that's downward in the y direction. So the y component and the gravitational component are working together to equal the normal force, and the x component is equal to the frictional force. So again, in the x direction, the applied force in the x direction is equal to the frictional force, and the normal force is equal to the gravitational force of the sofa plus the applied force in the y direction. The x component of the applied force, right, we got 30-degree angle, is equal to the applied force, 125, times the cosine of that angle. And that tells us how much force was applied in the x direction. And the applied force in the y direction uses sine. So now we know how hard that applied force of 125 is in the down and right direction. So now we're going to set the frictional force equal to mu times the normal force. This is our equation for friction. And the frictional force, we said, is equal to the applied force in the x direction. So that's really going to be this number substituted here. We don't know mu, and we know that the normal force is going to be equal to mass times gravity plus the force in the y direction. So here's your mass times gravity, and here's your force in the y direction. Now we have numbers for everything except for mu, and we're simply going to use some algebra to solve for mu. What if instead of having a force at an angle, you had the entire scenario at an angle? Say a 33-degree incline causes a block to slide down the ramp. What is the coefficient? So we want to do a free body diagram. Again, we've got a gravitational force, but now it's straight down. We know the normal force has to be perpendicular. So how is that normal force balanced? Well, let's get a fresh diagram. The gravitational force actually consists of some amount of pulling it into the ramp. I call this the perpendicular force of gravity. This is the full force of gravity. And some amount of force pulling it down the ramp. I call that the parallel component. We've also got the normal force straight up and a frictional force pulling it up the ramp. Now, in order for it to be going at a constant speed, this frictional force has to be equal to the parallel component of gravity. So how can I figure out what amount of gravity is pulling it into the ramp versus what amount of gravity is pulling it down the ramp? Well, I know this angle here. It's actually the same as this angle here. And so I can figure out this perpendicular component by using, because that's the adjacent side, by using cosine. So if I do mg cosine of the angle, I'll get the perpendicular component. And if I use mg sine of the angle, I will get this opposite component, the parallel down the ramp component. So the force that's pulling the block down the ramp is equal to the frictional force pulling it up the ramp. And the perpendicular force pulling it into the ramp is equal to the normal force supporting it. All those forces are balanced. I can calculate the parallel force by using mg sine of 33 and the perpendicular force by doing mg cosine of 33. Now I can set these things equal to each other. Where the frictional force is equal to that parallel force, mg sine, and the normal force is equal to that perpendicular force, mg cosine. And I get mg's cancel out, sine of 33 over cosine of 33, which is 0.65. Let's say you are wondering whether a box will slide down a ramp. Really what you're wondering is the piece of gravity that's pulling it down the ramp greater than, less than, equal to the frictional force that's pulling it up the ramp? Well, there's also a normal force and a component of gravity pulling it into the ramp. They must be equal as well. So the gravitational force pulling it down the ramp is mass times gravity times the sine of the angle for the ramp. And the frictional force pushing it up the ramp is the coefficient times the normal force. Now we still need that normal force. Well, that normal force is going to be equal to the perpendicular component of gravity, which we just defined as equal to the normal force. So now we're wondering how this compares to this, substituting this for the normal force. Mass and gravity cancel out, so really we're just wondering if mu times the cosine of 27 is bigger or smaller than the sine of 27. In this case, the mu side, the friction side, is bigger. And so friction wins, it won't slide. One last example. Let's say you're pushing your 1,000 kilogram car up a hill with a 15-degree incline. What force do you need to push your car up at a constant speed if the coefficient of friction between your tires and the ground is 0.2? So we know that gravity pulls the car into the incline. It has a perpendicular component. It has a parallel component. There's a frictional force. Now here's the tricky part. The frictional force is actually going to be going down the incline if we're pushing it up the incline. So here's your applied force, your frictional force, and your normal force. The parallel component of gravity, this guy here, is mass times gravity times the sine of 15. That's that force. We can also figure out that perpendicular force, and that'll be equal to the normal force. We know that the force of friction is equal to mu times the normal force. And we know that the applied force has to counterbalance friction and gravity. So again, gravity pulls it down, so does friction, and you have to apply a force that counters those. So you have to add them together. All right, hopefully you found those examples somewhat helpful. Let me know if you have any questions. Good luck.